Now remember that a line has a slope, and the sign of the slope, the plus minus sign of the slope, well, the line is rising from left to right if the slope is positive. So the line's increasing in function terminology. If the slope is negative, that means the line is decreasing. And if the slope is 0, well, the line's just like flat. This is lines. But we can replace this idea with functions and replace the slope, of course. Now the slope is the instantaneous slope, the derivative. Cool? The derivative is the slope of the tangent line. But the slope of the tangent line is the slope of like the thing that's riding along the curve. So the feeling of slope in a line translates into a more curvy function as the derivative, but it's the same. If you see slope, at least in this class, you're thinking derivative. And if you're thinking derivative, you're thinking slope, which is what this question's asking. This question's asking for that opposite direction. This question's saying, if you know the derivative, then how do you know if the function's increasing or decreasing? This is the same as saying, if you know whether the sign of if you know the slope, how do you know if the line is increasing or decreasing? Well, you just look at the sign. If the slope is positive, your line's rising. If the slope's negative, it's decreasing. Same thing with the derivative. If the derivative is positive, the function's increasing. If the derivative's negative, the function's decreasing. And if the derivative is 0, the function is neither increasing nor decreasing at that point or at that interval, but rather it's flat. That is, for functions, this means the derivative f prime of x is positive. Oh, I'm going to make a nice chart here. Oh, this is going to be really nice. Okay. So if we have the derivative of x is positive, then x is increasing. And I see that as a good thing. Like, imagine that's your bank account. If the derivative is negative, that means that on the interval that this is true, the function's decreasing. That's kind of bad if it's your bank account. So you could think about plus, positive, increasing, negative, minus, decreasing. And if at any given points your derivative is equal to 0, well, your function might be flat. Certainly your tangent line is flat. This is saying the function is constant at that point. And usually this represents a peak. See, the tangent line is flat, or it represents a valley. See? Tangent line, flat. Now these peaks and valleys, these actually have names. The peak, by the way, is called a local maximum. I'm just going to put local max. See, for all of the values around there, it doesn't get any higher. Not till you scoot over a ways. And the bottom, the minimum here, that's the y value. The local max is the y value. However, whatever that is. And down here, the valley or trough is called the local minimum. I'm just going to write the local min. It's like for all the places around there, that's as low as you get. And it's also a y value. So you know that if you have a function and the derivative is positive, like literally you take the derivative and you plug in a value of x and you find that that's a positive number, or on the graph it's above the x-axis, Scott, then it's increasing. If you at that point or points, if you plug in an x value and it gives you a negative derivative at that value, then at that value the function is decreasing. And if you plug in an x value and it turns out it makes the whole thing turn to 0, then you know you've reached a peak or a valley, or you're in the situation maybe that the function is just a flat line. That's possible too. That derivative is 0 as well. Now, in the case of a problem like the one that we were looking at in our homework, I'm just going to draw a function. I'm going to draw a graph. So this is a function I just made up. No, this is the graph of the derivative of a function. We don't know what the function is, but we just assume that this is true. I think this graph could be true. That could be some function's derivative. Remember, the derivative is still a function. So you can still draw a graph for it. Take the derivatives of that graph to get the second derivative and all that. We'll talk about that next time. So what is the deal here? Well, from here to here, the derivative is greater than 0 on this interval. I don't know, let's say that this is -2 and this is +2 to make the numbers match the problem, even though it's not the same graph. So from -2 to +2, since the derivative is positive, that's what a function looks like if it has a positive derivative. That means the function is increasing. Now I left the brackets off of that interval. We haven't determined that yet. For all of these points, these x values, the derivative is positive, which means the function is sloped upwards. See, this is the derivative, not the function's graph. Yeah, it's sloping downwards there, but it's still positive, which means the original function is increasing. This is the derivative. But now when you get right here and there, so the question is, are these round brackets, which means those points aren't included in this interval, or are they square brackets, which means those points are included? So let's just think about this. What is the function's value there? Is it positive or is it negative? Or is it 0? What this is telling you is that at that point, that x value, -2, here, the derivative is 0, means the function is flat. This is going to be either a peak or a valley, because those are the places where the derivative is flat. That's what I was just drawing, right? If the derivative is 0, that's that case, it's a root, then the function, the original function, is flat at that point. So that means that the derivative represents a peak or a valley of the function. That's where the derivative is 0. You buy that? Okay, so now back to here. So that point where it's 0, the peak, that's the function's not increasing or decreasing there. It's just like at a tip. Or whether, I don't know if it's a peak or a valley, but the fact is that the point -2 is not included in the interval where the function is increasing. At that point, the function's turning around. It's flat. The derivative's flat. Same thing here. At this point, since the derivative's 0, that point is not included in the interval of increase because the function is turning around again at that point. So we know that on this interval, not including those endpoints, that's this interval, -2 to 2, open. Since the derivative is positive, it's above the x-axis, we know that the function, the original function, is increasing, because that's what a positive derivative means, just like right here. Cool? Now what about, are there any other places where the derivative is increasing? It looks like, let's make this be the point 4, just for fun. It also looks in this graph, we assume that that's going to keep increasing, that's going to keep going down. It looks in this graph like the derivative is also positive above 4. So I'm going to go ahead and put 4 to infinity. Just from 4 on up, it keeps rising. The derivative is positive, and what that says is that the graph, the original function, is increasing. It's rising from left to right. Cool? That's picking up the positive parts. Noting that at the point 4, it's also not included because the graph is turning around there if the derivative is 0. That leaves us with parts where the derivative is negative. I guess I'll go ahead and erase this little piece. Wait, I think I can fit this. I just won't draw as much. The derivative is less than 0. Happens here from -2 out to -infinity. And the function is also not increasing or decreasing at that point, so it won't be included. Because the derivative is negative, that means that f of x is decreasing out at this part of the original function, because the derivative is negative. Similarly from there to there, from 2 to 4, not including those points, the derivative is also is negative, so the original function is sloped downwards, it's decreasing, right? Because derivatives just slope. It's positive, it's increasing. It's negative, it's decreasing. It's 0, it's flat. And what does that mean? It means it's at a peak or a trough. Okay. That's basically how you break that down. That tells you, I think, so that doesn't exactly answer the specific question, but I do believe that it answers the all questions like that. So Scott, tell me if that works for you. I'm going to go one step further now, you all. I'm going to also tell you what it means if the second derivative is positive or negative.